You're listening to the Azure DevOps podcast, today featuring Damian Brady, talking more about Azure DevOps.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to another episode of the Azure DevOps podcast. Go online to www.azuredevops.show to see show notes and other episodes. I'm really excited to speak with today's guest, Damian Brady. Damian is a senior cloud developer advocate, helping customers implement DevOps methods on the Microsoft platform. Damian, welcome.
Thank you. Thanks for having me.
So we've known each other for a long time, but for the listeners who might not be familiar with you, you've worked for Microsoft for some time now, but you've done quite a few other things for the community previously.
Yeah, I've been at Microsoft for a bit over a year now, so a year and a couple of months. I previously worked for Octopus Deploy, so that was kind of where I got most of my deployment automation, stuff happening. And then before that, I was in consulting, and then a few financial services customers and things like that. So, yeah, a bit of a history in that kind of DevOps sphere, I think.
And you've done so many different types of software in a variety of industries. But Microsoft is such a large company, and even around the new Azure DevOps division, formerly VSTS, there's so many different groups. Which group are you presently on?
Well, right now I'm in the DevOps team of the Cloud Developer Advocates. So that's Donovan Brown's team, nicknamed the League of Extraordinary Cloud DevOps Advocates. So there's 5 of us in that group, and we focus very much on DevOps, but we speak a lot and we work a lot with the other Cloud Developer Advocates. So right at the moment, I'm having a bit of a focus on DevOps for data science and machine learning and things, which I think is an area that is lacking, I guess, in or not lacking necessarily, but could definitely benefit from some DevOps ideas, I think, which aren't always there when it comes to data science.
Oh yeah, I bet. I mean, any of these new project types, you're in Visual Studio and you're writing code, and it's an application type, and so as an application, it needs a build, it needs to be packaged, version tested, deployed somewhere. Yeah,
and I mean, a lot of the time it's not necessarily, like it's not used as a project type, or it's not done with Visual Studio. People will use things like Jupyter Notebooks to do a lot of data processing and things like that, and they use TensorFlow for building models, or CNTK, or Spark, PySpark, and things like that. And so there's a lot of other tools that data scientists are using. You can do a lot of this stuff in Visual Studio, but I think most data scientists aren't. And that leads to even basic things like, as we in the developer community would think of, like basic things like source control, which might not actually be happening in data science fields. The code or the data processing stuff. So, the SQL queries and the Python to filter stuff out and things like that, that might just be sitting on somebody's local machine until they create a model that does the correct, prediction or successful predictions, and then that's the model that gets used. But the process to get that model isn't really repeatable. It's just something that's on somebody's machine.
Okay. Well, let's talk about that more. But with the advent of the Azure DevOps release and the change from Visual Studio Team Services, what's the big change in the area of data science? What's going to be different for people building these models or running them?
I think definitely one thing is that the change to be a bit more vertical and vertical slices of different parts of the DevOps process will make it a little bit easier to kind of get on board. Visual Studio Team Services very much kind of was approached as a single product that did all of the DevOps things. So if you just wanted something to build and coordinate your releases to machines, then VSTS kind of might have seemed a bit like overkill. I mean, there's source control, there's testing, there's build and release, there's work item tracking and so on. And you might not actually want all of that stuff. Maybe all you want is a pipeline to put a built predictive model into a location. So I think Azure DevOps kind of verticalizing these and separating them into individual products definitely kind of reduces that artificial barrier. You can just use the pipelines if that's what you need, and you don't need to worry about the fact that there's source control available to you and work item tracking and things. Or you can just use source control if that's all that you need with the Azure repos. So I think it's a little bit more targeted at only use what you need to use. It's less targeted around you are a development shop and you need all of these things. So I think that probably improves the visibility and the kind of availability of this product.
Right. I think that's huge. Our first episode, Buck Hodges, the director of engineering for Azure DevOps, he talked about the different verticals that the previous VSTS product had been split up into in the relaunch with Azure DevOps. And that's, so many customers who can't maybe for historical or political reasons implement every piece of it. And now you think, oh, I just need a build server. I need to build and package and deploy. My source is already somewhere. I already track my work somewhere. That's awesome. Now, for the data science type projects, what does the source control look like? And you said it could be files somewhere, but you need to version them somehow, right?
Yeah. I mean, you definitely should be versioning them somehow. And I think it's a little bit like software engineering, where yes, of course you should do source control, but there's still places out there that don't. So I think that's an important thing. But there's additional concerns with data science, like when you're trying to build a predictive model, for example, you have a source of data, which is your input data, and that's kind of the most important thing. That's going to lead to the best models. If your data's terrible, then your model's going to be terrible. So there's also the concept of needing to version your data as well. I mean, if you're building a model on 2015 data, then that data is, you operate on that, you get knowledge out of that, you experiment, you filter, you tune that data so that your model can be built more accurately and trained more accurately. But then, 3-4 years down the track, you want to rebuild that model. You can't just use that 2015 data. You need to use more up-to-date data. And ideally, this should be a continuous process of tuning that data and using new knowledge to train that model a little bit better. So as well as just the source code, which might have things like data filtering, and whether that's SQL statements or R or something like that to kind of filter that data. There's also the maybe TensorFlow code or CNTK code to train that model. So that's source code as well. But as well as that, you're doing this on a particular set of data. So you need to make sure that data is versioned and kind of tied to the code that you're using to filter that data and to train that model.
Now, for the Microsoft ML, is there a particular format that the data is stored in source control?
Not really. And this is a bit of a problem as well, is how do you store, potentially terabytes of data in source control? It's a difficult problem.
It's a lot of data. That's just a lot of data. And if it does need to be versioned, and if it is that big, what are the current methods people are using?
That's a good question. And that's something I'm speaking to a whole bunch of different people doing data science day to day to find out what their process actually looks like. I mean, there are people, the problem is data can come from anywhere, really. We think about it, it could be images that have been caught on security cameras that are just stored in blob storage somewhere. Or it could be, public data from government departments that is in CSV files that, maybe are missing quotes every now and then. And so it's a horrible mess. I've worked in plenty of environments where actually there was a project I did several years ago, just privately, where I was looking at local council data in Australia for houses that have been built. And I was told, here is your data, or here's the data that's going to be presented to you. It's in one of 4 formats. There's 2 tab delimited formats and 2 CSV formats, comma separated. In one case, what I ended up getting was a Excel spreadsheet pasted into a Word document sent to me. So, yeah, the data can honestly be anything. So this initial process of getting it into a format that is that you can operate on, that you can filter and use. That's a big part of this as well. So, yeah, it could be in a SQL database, it could be blob storage, it could be files on somebody's hard disk, it could be photos that are stored on Flickr, it could be public information on the internet, it could be really anywhere. And so, pulling that data in and saying, this is the data that I'm operating on, and this is the data that I use to train this model, and do that in a repeatable way is a tricky thing to do.
With that, let's take a quick break for our sponsor.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
And we're back talking with Damian Brady about DevOps for data science and machine learning. So you have to have this pipeline with whatever it consists of. What are the interesting architectures that you've put together for machine learning?
Well, the really cool thing at the moment is that we're kind of getting into this age of commoditization of AI, or even democratization of AI, which means that using machine learned models, or using your own custom machine learning stuff in your application is no longer this gigantic barrier where you need a PhD to understand what's happening. You can use Azure Cognitive Services, or there's equivalents in AWS and Google as well, but you can use these services not just to give you out of the box, what is in this image, or what does this handwriting say, but also to train it on your own data and get models out the other end. And part of that has been this ability to get models out the other end that are things like Docker containers, or pre-compiled TensorFlow, predictive models as well. So one of the things that I did recently is there's a custom vision API or custom vision service that Azure does, which if you wanted to have a play with it, it's actually free to have a pretty good play with it, customvision.ai. It allows you to export certain models that you can create, so object detection and things like that in photos, and you can export them as a Docker file, a Docker container, or as CNTK or TensorFlow, or the ML format that is used for iOS, which just escapes my mind at the moment. So you can actually use these on devices. So what I did for a keynote I did recently is actually got that machine learned model, that exported model, running on a Raspberry Pi. So the Pi could take photos and then tell you what was in the photo offline. So you didn't even need to call back to Azure or anything.
No, that's running Raspbian?
It was running Raspbian, yeah. So I needed to get a few things running on Raspbian for that to work. And along the lines of this
kernel.
Yeah, it's Linux one, yeah.
So how did you deploy to it? How did you hook that up?
Yeah, so that was the fun thing. I just did a little bit of stuff just to make sure it would work on the Raspberry Pi. And then, of course, because I'm a DevOps guy, I didn't want to just copy the file across every time.
Yeah,
of course. So my code is in source control, the code that the Raspberry Pi runs to take the photo and identify what it is. But as well as that, the exported model is in source control. So I need to improve this process to include the build and the pulling down that model. But at the moment, all I did was create a release pipeline in VSTS, which it was at the time, and run a deployment agent on the Raspberry Pi.
So you took the Linux agent from Azure DevOps and installed it on Raspbian, and
Kind of. So the Linux agent won't run on Raspbian. However,
Okay.
the agent itself and a lot of stuff inside XVSTS, but inside Azure DevOps is open source, including the
course.
agent itself.
Nice.
And so it's written, I think, in .NET Core. So, of course, you can pull down the source code and build it locally on Raspbian because .NET Core runs fine on Raspbian. It's just a Linux flavor. So I compiled it locally on the Raspberry Pi and ended up with an agent that can just talk to Azure DevOps.
And how many changes did you have to make to the code?
So I didn't have to make any changes, which is fantastic. But Edward Thompson, who's on the Azure DevOps product team, he made a few changes. Not a lot, actually. I had a look through his pull request for that project, and the changes seem to be primarily just identifying the different architecture of the Raspberry Pi. So just to say, I can also run on this. So that was pretty much all that needed to change. Like the code itself didn't need any big changes at all.
Okay, so your production environment is a Raspberry Pi, and this is a machine learning model. So you walk us through from source control to building to packaging up that release to deploying. How was that implemented?
So I'll tell you how it was implemented, but I'll also say what I should have done if I had a little bit more time. So the way it was implemented, it was just Python, which was in a GitHub repository. So the Python just lives in GitHub. It's a public project, so anybody can grab that if they want. And then inside there, I just have a single file, which is my predictive model, which is exported from the custom vision AI. And the predictive model is just in a folder alongside the different labels that I want to identify in my objects. So what I did is I downloaded the predictive model, which is an export from custom vision AI, and I added that to my source repository and committed it. What happened then is the release service in Azure DevOps grabbed that source code because I didn't need to compile it. It's just Python. It grabbed the source code when there was a change, and it deployed that to a target, like a deployment target, which was the agent running on my Raspberry Pi. I actually added a couple of little additional Python scripts on top of that, so that when it was deploying, the little, I use a Sense hat on the Raspberry Pi, but there's basically a 8x8 grid of LEDs. They went yellow when it was deploying and then green when it succeeded or red when it failed. Okay. And that was just defined in separate Python scripts. So that just deployed it directly from source code straight to the Pi. Now, what I didn't have in this pipeline, which I really should have, is the ability to do some data refresh. So if I came across a whole bunch of new pictures that identified the things that I wanted to identify, having those uploaded to custom vision, retrain that model, and then add that model to my source code, but then as well have a pipeline which kind of stops it if that model has not improved. So I could actually run tests against that model with known photos that I had to say, is this trained model that I've just created, has that model improved my prediction or not? And if it hasn't, then I don't want to actually deploy it to the device. It's like a build that fails, or it's like a release that goes to your QA environment and doesn't get signed off. So I could do that automatically. Yeah, I could test that predictive model and say, look, this is actually performing worse than my previous one. Let's roll back to the other, or not roll back, but let's not deploy this out to production.
Yeah. And so for this type of model, where would be the physical environment where it's measuring information? So
in production, you mean? Or,
right.
Yeah. So I think something like this, and this is it was demo software, but this is an example of something that you could use maybe in a factory. So you might have a conveyor belt which has a couple of different products coming down that conveyor belt, and you need to shuffle them to, the left-hand side or the right-hand side. Something like custom vision is great at identifying, and labeling a couple of objects or different objects. So I could have these two objects coming down the conveyor belt, a Raspberry Pi taking photos or streaming actually photos that it was taking from the camera, and then shuffling individual objects off to the left and right as it identifies them.
Okay.
I'd probably need to do a little bit more work to want to put it in a factory, but that's the kind of thing that a model like that could do.
Okay. So I'm just thinking about the network topology in this factory, and thinking back to one customer and asking about firewall rules and how to actually connect all these things up, and thinking, okay, we have Azure DevOps services up there in the cloud.
Yeah.
I don't want to open up a firewall rule so that somebody from the outside can poke in and then start talking to all these devices. But you installed that agent on the Raspberry Pi. So whether there was 1 or 50 or however many of these guys, all they have to be able to do is access the Azure data center where their Azure DevOps services project is running, and they phone home and say, hey, is there anything for me to do? Do I need to deploy a new version of this software, which happens to be the model, right?
Yeah, absolutely. And I mean, you could even have an offline process where, for the most part, these devices are offline. However, if you wanted to do a refresh of that model, you can take the Pi or whatever the device is into an office, plug it into a network cable, and then run the agent. It can call out and say, is there any work for me to do, and pull down a new version. But you're right, that agent itself runs on the device, and it only calls out to Azure DevOps to say, is there any work? So there's no firewall rules to poke holes in the firewall for 50 or 100 devices.
Right.
They all act independently and call out and ask for the work to do. The other quite cool thing about this is most of that work happens on the agent, which is physically on the device. So any kind of security that you need on the device itself, it's running on that device. It's not a machine somewhere out in Azure that Microsoft controls trying to do stuff inside that Raspberry Pi.
Right.
Reaching in and trying to get permissions and things like that. It runs on the device. So that agent can be given as many or as few permissions as you need.
Yeah, that's fascinating. Whether it's machine learning or any of the other IoT implementations, you have some device that's somewhere that's not this perfect office environment with fast Wi-Fi and water meters and oil and gas fields and other. You have to find some mechanism to get some type of network connection at some frequency in order for it to communicate. And so, but more and more of these factories, of course, are installing Wi-Fi. But out in the oil and gas fields, I mean, they use intermittent cellular connections and satellite link ups. But it's fascinating. If you can get an IP connection at any point, this architecture would work.
Yeah. So one thing I would say as well is that there's another service that Azure has, which is the IoT Hub, which is probably actually better suited for this kind of of work. So if you have 100 devices and they're tiny little devices on thermostats or on devices out in oil and gas fields, the advantage of having Azure IoT Hub is that it kind of has a duplicate of that device stored in the cloud. So it knows what version of the code and what version of the firmware and things like that should be on that device. And then it can sync them at its own time. If you had all of this stuff with predictive models and so on as part of your pipeline in Azure DevOps, then it's just that last step that you would need to change. So you can still do all of this DevOps for your data science, for your machine learning, and then just the final deployment step, rather than deploying that to the Raspberry Pi using the deployment agent, you would just tell Azure IoT Hub, you'd say, look, there's a new version of this firmware, a new version of this model. I'd like you to deploy it out to these devices, please. So the whole DevOps process is the same except for that last little bit. And that, if you have more than one device or hundreds of devices and they're offline some of the time, that's probably realistically a better way of doing it.
I gotcha.
But the rest of the process can definitely be done with Azure DevOps for sure.
Awesome. Well, that's fascinating. And you're certainly doing a lot of work with DevOps for data science. But as I understand it, you also do quite a bit of open source work, and there's some open source goodness that's quite new. Some people have heard about it. Why don't you tell us what that is?
Yeah. So when I set this thing up for the Raspberry Pi, all my code was in GitHub. There's some pretty good integration with VSTS, which is what I was using with GitHub. But with Azure DevOps, with this release, that integration is a lot deeper. And we've also added a few niceties for the open source community. So the short version is, if you have an open source project where your code is on GitHub, or in fact, if it's on Azure repos as well, if it's an open source project, then you have build and release pipelines that you can use for free with the hosted agents. You can actually have, I think it's 10 parallel tasks all at once running from your open source project. And then there's some really nice things. There's an extension in the marketplace for GitHub, which integrates really nicely with with Azure DevOps. I'm going to have to get used to the new name. Integrates really nicely with Azure DevOps and gives you things like pull requests, builds and rebuilds and things like that, and build badges that you can put in your Markdown, in your README, and all that kind of stuff in GitHub. But the short version is, you don't have to pay for your builds or your release pipelines at all for open source projects.
Yeah, that's fantastic. At the MVP Summit, I think as early as last year, but definitely this past spring, there was a lot of people asking to be able to kind of do what's on GitHub in at the time VSTS, and I think it looks like this open source offer combined with public projects was kind of a response to that. Whereas you can put a completely out in the open project and a public project, and then you have your free build and deploy pipeline. And even if your production environment is a public NuGet feed, well, you still need a pipeline of some sort.
Yeah, definitely. And it's kind of an acknowledgement in this product of the way that Microsoft has been heading for a little while. A lot of this code, as I mentioned in VSTS, is open source. So the build agents, build and release agents, and even the deployment agent, all of the tasks, all of the build and release tasks that are out of the box are open source. There's a ton of stuff that's open source. And so we're kind of open sourcing a lot of our stuff, but this is another step forward of saying, well, if you have open source software, then you need a pipeline. We will just give you one. So you don't pay for this. You don't need to give a credit card. All of the visibility is open for everybody if you want it to. It's free. And then we can even have public projects where some of this stuff is exposed inside VSTS as well. But yeah, the build and release pipeline, totally free for open source projects.
Yeah, so much of it, I've watched on GitHub the various projects of the Microsoft teams, and you mentioned they're open source. You can see every commit that's happening and even discussions around it. Do you still encounter some customers who say, "Oh no, we're not using that Microsoft product. We're an open source shop"?
Yeah. It's there's actually a bit of that's improved a little bit in the last couple of years. I think a couple of years ago, I was at an open source OSCon or OSCon, which is in Austin, isn't it? Or was in Austin that year, I think.
It has been, yeah.
It has been, yeah. I think it was that year. And there was a big Microsoft booth, and the number of times I heard people saying, "Why is Microsoft here? This is an open source conference." Yeah. Speaking to some of the cloud developer advocates who were at the most recent OSCon, that opinion has changed. Definitely, like a huge amount. People are actually seeing the open source stuff that Microsoft's doing now and appreciating it for, legitimate open source rather than, virtue signaling or kind of, saying, yeah, we do open source as well. It's legitimate open source. Projects like VS Code and .NET Core are probably two of the largest open source and most active open source projects on GitHub.
Yeah.
And they're done completely in the open, yeah.
I heard some stats that VS Code was the most popular editor for Node.js developers.
Yeah, we keep seeing that actually. VS Code is amazing. It's actually, and this is a weird thing for somebody who works at Microsoft, or it's actually not, but some people see it as a weird thing. My primary operating system is Mac OS. I'm talking to you. It's recording on a Mac at the moment, and my primary dev environment now is VS Code. So I don't actually boot into Windows very often at all anymore. VS Code kind of has everything that I need and then more. And Azure DevOps is browser based, so I don't need any particular browser. It's very it works great in any operating system. I actually, and this is a little side note as well, I actually got VS Code running on the Raspberry Pi as well, on Raspbian. So I can make little changes. Yeah.
Why did I mention that?
Yeah, I just thought I'd throw that one out. But that's an example, right? The build and release agent that's running on the Raspberry Pi, I was able to do that because it's open source. Exactly the same thing with VS Code. I was able to run that on my own operating system or on Raspbian because it's open source. I was able to compile it on that machine. There's definitely advantages to us open sourcing a lot of that stuff, and we're making great progress, I think.
Yeah, one of the huge advantages, sure, you could do a pull request, but sometimes a piece of software is intended to run on a particular platform, and maybe there's nothing in particular that should prevent it from running in other places, but it just wasn't built for that. And if it's open source, then somebody doesn't really have to know how to change it a lot, but if they just recompile with a different target and maybe one or two tweaks, now it runs on a different type of computer.
Yeah, absolutely. And that's pretty much what we do with that release agent or that deployment agent. There's a blog post basically describing what I needed to do. But most of that work was done by Edward Thompson. It's a very small pull request, but it was enough to be able to run it on my own flavor.
Nice. Well, that's really interesting. We see build agents on laptops or desktop computers just under a desk because, hey, it's a fast computer and it's always there versus a on-demand build agent that has to be spun up. I mean, seconds are precious sometimes, and if you have an extra machine, why not? But
sure.
You could for if your IoT project or whatnot, any type of machine will do. If you have a spare Mac Mini, there you go, boom.
Yep, exactly. Or even the hosted agents, the different flavors of hosted agent inside Azure DevOps has increased lately as well because we've been doing the same thing. We can just run a Windows container, which has a build agent in it, which is a fairly new one. There's a couple of flavors of Ubuntu. I think there was another one I saw the other day as well. So that used to literally be Windows or Linux. And then it was Windows, Linux, and Mac. And now it's Windows, a few flavors of Linux, a Mac, a container, a Windows container. So there's a few different options because, same agent, we're just compiling it for different environments.
Now, are those GA or are those in preview?
I think they're in preview, but I probably should have checked that before I was talking about it. Let me let's see if I can really quickly find out. But those, it's the same agent. It's just running on different infrastructure. It's really just whether the container spins up and runs and does your build and then spins down again fast enough, I think. Looking
at the list here, the hosted VS 2017. We do have a hosted Linux preview, and Mac OS is still in preview, but there's the hosted Ubuntu 1604 and then hosted Windows container.
Yes.
That's interesting. So there's not a Linux container, but there is a Windows container build agent.
Yeah. That one, I was actually on leave for a little bit and I came back and went to choose a agent pool, and that one showed up. So this is something you get working at Microsoft when we start doing our own, or when we've got these products that are continuously deployed, like Azure DevOps. Occasionally, you'll just see something different, and I'll reach out and say, "Hey, when did this happen?" I'm like, "Oh, that was 2 releases ago. I just hadn't noticed."
And it's not even labeled preview. And if you've never used one of these, if you click on pool information, it tells you exactly what's installed and what's available in that environment. And so this container image has Docker version 17.06 and some change, Docker Compose, some various Docker images in there, Git, Subversion, Chocolatey, and it kind of lists all the various things that are in that container. That's interesting.
And what's interesting actually is when you spin up one of those agents, it actually scans the local environment to see what is available to that agent. So when I ran this on the Raspberry Pi, I mean, VSTS or Azure DevOps doesn't know anything about what runs on my Raspberry Pi. Yeah. But the agent, when it spun up, did a scan, and there's this whole big list of all of the capabilities of that Raspberry Pi. It knew that Python was installed. It knew that .NET Core was there. It knew what the flavor of Linux was, or the name of the flavor of Linux, and all this kind of stuff that you can use to say, when you have your release or your build, to say, I only want you to run on things that have Python 3.x installed.
Yeah, right. And if it meets that criteria, then great, that's available.
Yeah.
Awesome. Well, this is a lot of great information. Thanks for sharing that with us. As we wrap up, what should our listeners do to go further with DevOps for data science?
Good question. I think stay tuned. What I would definitely say is check out some of the AI stuff that Microsoft is offering, the cognitive services stuff. There's a really nice entry points to artificial intelligence and to machine learning for people. And then stay tuned for being able to get that stuff running really nicely as part of your development process. It can be done right now. Definitely think about the process of, model and data refresh and testing your models and building them out and deploying them to their locations and that kind of process. And kind of try and include that in your application process, the data science part of that, version control and testing and things like that. They're all really important for repeatable stuff.
Awesome. Well, hey, thanks so much, Damian, for visiting with me. It was great.
Yeah, no problem. Good to have a chat.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.